So in this part, we're going to talk about when you have an exponent raised to another power. So in this example, I have 3x to the 4/5 power being raised to the 2/3 power. So when we're having an exponent on the inside and an exponent outside the parenthesis, you're going to distribute 2/3 this outside exponent to all the exponent inside. Now to review, this number coefficient has a invisible 1 exponent. So we're going to distribute 2/3 to both exponents that are inside, the 1 and the 4/5. So when I do that, I'm going to have 1 times 2/3 x, where it's 4/5 times 2/3. So 1 times 2/3, and I'm only talking about the exponent, would be 2/3. So I'm going to have my number base 3 to the power of 2/3. For my x, when we're multiplying exponents with fractions, we're going to multiply straight across. So 4 times 2 is 8, and then my denominator 5 times 3, which will be 15. Alright, from there, since we do have a number coefficient with a rational exponent, then I'm going to convert this into a radical form. So it's going to be 3 to the second power being cube rooted, and then x will simply be on the outside. So x to the 8/15 power. Now I'm going to simplify the inside because it's 3 squared, which you can do, which is 9, but it's still going to have the cube root because you can't cube root 9. And I'm going to have x to the power of 8/15. And that would be my final answer. Now what's different about this example compared to the other ones is that my number coefficient had a rational exponent, and in order to simplify, I convert it into a radical expression where it was the cube root of 3 squared. I can do the 3 squared, which is 9, but I cannot simplify any further because there's no cube root for 9. And then for the variable, when you multiply with a rational exponent, you simply multiply straight across, and that's how I got 8/15, and that's pretty simple. But when it comes to number coefficient, if it has a rational exponent, then it's best to simplify, and sometimes it's easier to convert to radical form. In this example, I have 8m to the power of 3/7 being raised to the power of 2/3. So the whole thing that's inside the parentheses is raised to the power of 2/3. And remember, this 8 has an invisible 1 exponent. And I'm going to distribute, since it's being raised to the power, the 2/3 to the 1 and the 2/3 to the 3/7. So what I'm going to have over here is 8 to the power of 1 times 2/3 m to the power of 3/7 times 2/3. Alright, for the 8, 1 times 2/3, and I'm talking about the exponents only, will be 8 to the power of 2/3. For the m, multiplying with fraction, for the exponent, we're going to multiply straight across. So 3 times 2 is 6 in my numerator. 7 times 3 is 21 for my denominator. Alright, so once I finish multiplying the exponents for the number base and the variable base, then I'm going to simplify the variable base by converting to radical form. So it's going to be 8. Since it's 8 to the power of 2 or 3, it will be 8 squared, but it will be cube rooted. Here's my radical form, and my m will stay the same, 6 over the power of 21. So here's my rational exponent. Now, for the cube root of 8 squared, I'm going to simplify the inside. So 8 squared is 64. And it's still being cube rooted, while my m stay the same, so I still have the power of 6 over 21. Now, looking at my radical form with the cube root of 64, I notice that I can do the cube root of 64, which will be 4. So I'm going to write 4, and again, my m with the rational exponent 6 over 21 will stay the same. So here, my final answer is 4m to the power of 6 over 21. And that would be my final answer. So in this case, in this example, we do have a number with a rational exponent that was able to simplify all the way into a number base with no radicals.